In this video, we are going to do these 5 questions from the chapter probability. Well, few of these questions will involve this formula, that is the formula that you have done in set theory, and also we'll be using this combination formula. So let's begin with the first question. In this question, it says in a town of 6,000 people, 1,200 are over 50 years old and 2,000 are females. Further, it says it is known that 30% of the females are over 50 years. And what we have to find out is the probability that a random chosen individual from the town is either a female or over a males. So first we will understand using a Venn diagram. Let's say if I say this is the total number of people, say n of s, which is given how much, which is 6,000. And then there are, let's say if I take this as people above 1,200 years old, and the other I should make female, right? So we know that here, n of say if I take a, and how many of them are this? These are people which are above 1,200, above 50 years, which is 1,200. And then we look for the female that is say the green one. So if I take say n of b over here, and this is how many? These are females, and they are how many numbers? 2,000. But then it also says that if you look into this, 30% of the females are over 50 years. So that means we are talking about this portion, right? They are female as well as above. They are female as well as what? 50 years above. So this is clearly, that is PA intersection B, right? Common to both the reason. And that is 30%. So 30% of what? Females, and the females are 2,000. 2,000. So we can reduce it as comes out to be 600. This is PA intersection B. Intersection B is this much. Now coming to the question, what we have to find out, what is the probability? Let me read it again. What is the probability that the random chosen individual from the town is either a female or 50 years? So that is, so now it's very clear that we have to find the probability for this reason. But before that, we need to find their numbers. Okay, fine. There is a mistake. This also is not B, right? This is the number we got of A intersection B. So first I'm going to get N A union B here. N stands for the number, which is by the formula N of A plus N of B minus N of A intersection B. So we can get this as N of A union B as, what is N of A from here? This is 1,200. Plus n of b, which is 2,000, minus their intersection is how much? 600 from here. So this way, 12 minus 6, 12, that is 2,600. So once we get this, now we can find the probability of PA union B should be what? The favorable, which is 2,600 divided by total, that is 6,000. It can be reduced. These rows can be cancelled. This is 2 13 times and 2 30 times. Yes, so the required probability we got as 13 over 30. That's how we will do this question. In this question, it says 4 cards are drawn at random from a pack of 52 cards, and what we have to find out is the probability of getting all 4 cards of same suit, and the second is all 4 cards of the same number. So let's do with the first part, all 4 cards of the same suit. So there are 4 suits, right? One for diamonds, hearts, clubs, and spades. There are 13 each in number, right? 13 each in number. And we need 4 cards, either of hearts or 4 cards of diamond and so on. So we can say that if I say that if all 4 cards are diamonds, then it should be taking out 4 cards from 13 diamonds. But then it's a possibility that it could be 13C4 for clubs, or maybe 13C4 for the other pattern diamonds, or maybe spades and so on, right? So this is what the total number of ways of taking out 4 cards, right? So we'll call this as favorable outcomes, and the total outcomes will be what? Total outcomes, as we know, we are taking out 4 cards from 52. So it should be 52C4. So we can simplify it further. We can write 4 multiplied by 13C4 over 52C4. That's how we'll do the first part. Now, if I see the second part over here, second card says all 4 cards of the same number. So same number, what does it mean by same number? It means to say that like cards are numbered what? That's ace, then 1, then we have 2, and so on. It goes up to 10, then there is a jack and king or queen. Let us say if I write queen first and then king. So there are 13 cards. And there are 13 numbers. So we can say that there are 4 aces, 4 twos, 4 10, 4 jack and all. So we need all these 4 cards from the same number. That means either we need all 4 aces, right? Or I need all 4 10, right? All 4 10 and so on, right? So we'll say that there are 13 ways, 13 such pattern. So 13 multiplied by 4C4, and the total number of cards taking out is same, that is 52C4. So this is the favorable and this is the total. So we'll say that this is how we can calculate the probability that all 4 cards of the same number. And the next question is says a bag contains 8 red, 3 white and 9 balls, 9 blue balls, sorry. And if we are taking out 3 balls are drawn at random. We have determined the probability that in the first part, all 3 balls are blue in color, and the second when all balls are of different color. Right. So let's do the first part over here. What we can see that we have how many red balls. So if I use R, red is 8 and white is 3. And how many blue balls are there? There are 9 of them are blue balls, and we have to take out 3 balls. What is the first part is all 3 balls are blue. That means this way we can say that we are taking out 3 and 3 of them are blue. That means the 3 must be taken out from these 9 balls. But then this is what the favorable, right? But the total number of ways of taking out 3 balls from how many balls? That is 9 plus 3 is how much? 12 plus 8, 20. 20C3. So taking out 3 blue ball from 9 blue ball is 9C3. And taking out 3 balls from 20 balls is 20C3. That should be the way of doing the first part. Now see the second part, it says all balls are of different color. Now we are taking out 3 balls and we have 3 colors. So that means we must have 1 8, right? 1 red, right? And then we should put a multiply sign because this is an and we have to take out from the 3 white, we also need 1 white. So 3C1 multiply. There are 9 blue ball and we need 1 ball of blue in color. So that is 9C1. But then the total ways of taking out 3 balls remain same from 20 balls. So this is say if I use PA for the first part and PB for the second part. This is how we will do these 2 parts in fact. In the next question, he says a young man visits a hospital for medical checkup. The probability that he has lungs problem is 0.45, heart problem as 0.29, and either lung or heart problem is 0.47. And what we have to find out is the probability that he has both types of problems, lungs as well as heart. There's an additional part. Let's do the first part and then we'll do the second part. So let's say this is a Venn diagram I should make. Now we have 2 problems here. That is one for heart and other for the lungs. Now let's say if I take the first one as the lungs problem. So we know the probability for the lungs problem. So that is has lung problem is how much? 0. So PA is how much? 0.45. And for heart problem, that is PB if I take, and this is how much? 0.29. 29. And either is what? Either means this whole thing, right? So we even know what is PA union B is given to us as how much? 0.47. Now, what we have to find out is common, right? Heart as well as lungs. So we can say that we have to find PA intersection B. This is what we have to find out. So we can do so by applying the direct formula. We have what? We know that PA union B is equal to PA plus PB minus PA intersection B. And as you can see that we have all information mentioned over here. To get PA union B, we can plug in the values. So we know PA union B and how much it is. Union is given 0.47. 0.47 minus P of A is 0.45. 0. What we can do is straight away plug in the value as this is equal to, right? There's an equal to sign over here. So PA is how much? We get PA is 0.45 and plus PB is how much? 0.29 minus PA union B is what we have to. So PA intersection B is what we have to get. Now what we can do is to keep this PA intersection B on the left hand side on transposing. So we are going to add these two, right? So 45 plus 29 is what we are going to do and should give you 0.474, sorry, 74 and minus this, that is minus 0.47. So if I subtract 47 right from here, it should give you 0.27. That's how we will say that the probability in this case is 0.27. Now there is an extended part of this question. Here in this part, it says out of the 1,000 persons, how many are expected to have both the problems? Both, that means the union, right? Uh, so both is what? No, both is, sorry, intersection, right? So we can say we have to find out number here, number of A intersection B, not the probability. Right. So it's what? Probability is 0.27. So if it is probability is 0.27 multiplied by the number which is 1,000. So it should give you how much? 270. Yeah. Out of 1,000 people, you can say that there are 270 people having both the problem out of 1,000 people. Right. Now in this question, it says a class consists of 10 boys and 8 girls. 3 students are selected at random. What is the probability that the selected group has all boys? So we can see that the boys number are 10, the girls number are 8, and the total students we can say is how much? 18. So first case is where all of them are boys. So that means ways of selecting 3 boys from, right? We are selecting 3 students. So all boys, that means from 10 boys, we are selecting 3 boys, right? And these 3 students so selected from how much? Total of 18 students. So 18C3 should be the required answer. Say if I use PA for the first part. Now, similarly, we can see for the second part, all girls stands what means? All girls stands means that means we have 8 girls and we need 3 girls. So from these 8 girls, number of ways of selecting 3 girls from 8 girls is 8C3 and the total number of ways is 18C3. Now in the third part, say if I say PC over here, this is 1 boy and 3 girls. So we need 1 boy from here, right? That means from 10 boys, we need 1. And then we should put a multiply, not plus sign, because we need 3. And that's what and comes here. And 2 girls, that means from 8 girls, we need 2 girls. So that is 8C2. But then we are taking out 3 students from 18 students. Now, this is the probability. And now if I use PD for the next part, so to find out the probability for the Fourth part is at least one girl. So at least one girl means 1 minus probability of no girl. So this is 1 minus no girl means all boys, right? Or no girls means all boys. That means all three are selected from, all these three students are selected are boys only. And that divided by total ways of taking out, that is 18C3. That's how. Now for the fourth part, it's at most two girls. So at most two girls means maximum two girls. So it can be zero girl, one girl, or two girl. So take the condition this as what we are left with PE if I use. So zero girl stands with all boys, right? Zero girls stand with all boys, which we have already got. All boys means this is three. Zero girls stands for one, all boys. Or that's why we should place plus. One girls means out of the eight girls we are taking, out of the eight we are taking one girl. So definitely the remaining two must be boys because we are selecting three students. So 10C2. The third is what? Third case when there are two girls. So from eight girls, if you are taking two girls, right, the remaining one is what? Has to be boy. 10 boys are there. So 10C1. But then the total ways of selecting how many? Three students from 18 students will be this only. So this would be the, after calculating, you'll get the value of probability for the fourth part. And here at most two girls stands for zero girl, one girl, or two girls.